and quite exciting keynote discussing some approaches that are maybe not really in the ENW style. But now the tech track will go on, and I may introduce Marco Slaviero. He's from SensePost, from Africa. SensePost is quite common for publishing some tools for web server testing, web application testing. So when someone is working in the community, he's well aware of SensePost. And Marco will present some stuff about cloud security, clobbering the cloud. The talk will be 2 hours long, so it's a double feature talk. But Marco told me he will do some kind of 5 minutes break in the middle, so you will have time to have a cigarette or what else, grab a coffee. Yeah. So don't worry. Okay, let's have fun with clobbering the cloud.
Thank you very much. Welcome to this talk, Clobbering the Cloud. This talk is one that was presented last year at Black Hat USA in Vegas, and it was 2 colleagues and myself who put together the presentation. And this year we were invited to Troopers, and we're quite grateful for the opportunity. So definitely thanks to Enno, Florian, and all the rest of the guys who gave us this opportunity. This talk is a talk that covers, I think, what you'll find quite a broad spectrum of issues that relate to cloud computing and cloud computing security. And it's quite a fast-changing field. In fact, the definition for what is cloud computing, as we'll see, is also something that changes quite rapidly. So there's some forward thinking here, or we hope. There's some things to look out for. And there's quite a few videos. Because of the nature that is cloud computing, it's kind of hard to do live demos. So we've got a whole bunch of videos that I hope will suffice. So Harun and Nick were my colleagues. My name is Marco, and we're from SensePost. So just a little bit about us. We are from South Africa. It's right at the south end of Africa, so it's quite an easy place to find. We're hosting the Soccer World Cup now in 3 months' time, so you'll probably see football, and you'll probably see a lot of mention of South Africa at that point. If you see Pretoria at any point in the coverage, that's where SensePost is based. Little city, sort of under 1 million people, but it's quite close to Johannesburg, which is the industrial and economic hub of Africa, not just South Africa. And within our company, we're not that big. We're sort of under 20 people, but we've been going now for almost 10 years, and it's been quite a fun ride. Why should you listen to us? Well, you don't really have to. We've got a few things behind us. There's some books. We talk fairly regularly. We release tools, and we try to be active. So we are kind of involved. But just to give you an idea of what I've come from. So I live in Cape Town, actually, and when I left Cape Town on Monday night, it was 40 degrees. And to me, when I landed here, it felt a little bit like this. Now, I'm sure you're probably laughing at me saying this isn't cold. Wait till you see November or December when it gets to whatever, sub-zero. But it really does feel cold for me. But I must say, it's been quite an education. It's my first time really in Germany, so the trains run on time. This is something that I am impressed by, coming from South Africa. So the one question, or let's get this question out the way. Why are we talking? Why did we go for this cloud computing topic? Because it's a topic that's filled with a lot of hype, which I'm sure you'll agree. And so when it comes to cloud computing, we specifically, well, not necessarily just cloud computing, but at SensePost we specifically don't always go for hypey talks. So we are known for some of the slowest tunneling tools you'll find, things which have very little bearing on what's actually hot at a given point in time. But we do think that there's something important that's happening in the cloud space, and we think that to a degree some of these broader issues are being missed. And so we think that there's a lot of cool stuff. For one, that can be had on the cloud space. But we also think there's some messages that need to be said. And as we go through this, you'll find that one of our messages is that it's not the time to split hairs over individual technologies. It's not the time to split hairs over the definitions of what fits within cloud, what doesn't fit within cloud. It's such a fast-changing field, or it's such a fast-changing corner of our industry, that actually we need to be fairly open to things, and to be open to some of the services that are going to come out of the cloud space. So, a lot of people talking about cloud. As you can see, there's a lot of loud in cloud. Within all the people that are talking about it, so there's some who are incredibly positive about it and telling us that it's going to change the way that we do business and interact and all of these cool things. But there's also a separate group of people who are saying that there's nothing new here. It's exactly the same as Multics in the 60s. So if we're going to appeal to authority, Bruce Schneier is a reasonable authority, and he's on record as saying that there's absolutely nothing new when it comes to cloud computing. It's everything that we've known before. But this is because we're splitting hairs over the definition of, okay, well, when we specifically define cloud computing, we're saying that it's just a service that runs on someone else's computer. It's time sharing. It's nothing new. Let's not split that hair. Let's look a little bit broader. There may be cool things here. Let's not fix ourselves into that definition so quickly. So possibly we need to talk a little bit about what I consider, or what we consider to be cloud, and the things that we consider to be within scope. And this diagram sort of sets out one definition of cloud computing, and it's from NIST in the USA. And pretty much they divide it up into these three sections. They say there's characteristics, service models, and deployment models. And if we talk a little bit about the characteristics that we expect of every cloud service, or that NIST would expect to see. So the big one there is going to be resource pooling. So it's intuitively what we think is cloud computing. You share machines, you share time with someone else. Okay, so in that instance, it's kind of like Multics, right? Unix or whatever operating system that's come since then, in which you can, it's a multitasking operating system. You can run processes, and other people can also run processes at the same time. But there's resource sharing, and this happens on a really broad scale. So it's not just one processor that you're sharing. Maybe you're sharing network attached storage with, or storage area network with hundreds of other users. And so you are sharing many, many resources, and there's a lot of resources to go around. But there's other aspects that make it different from simple time-sharing systems. So for example, you've got on-demand self-service. So if you want a particular cloud service, you go to a website, maybe you fill in a form, you hit submit, now you've got it. There's very little human interaction. You don't have to wait for someone else to hit approve, or someone else to sign off, or you don't have to wait for the support team to come back to you and say that they've managed to do this. It's on demand. When you want it, you can have it. It's mostly accessed over networks. So the cloud, when you see it in the fuzzy network diagrams, always sits out there, and there's a little cloud, and there's just a link that connects you to the cloud. But that's one of the features of the cloud, is actually you don't know where it sits. It's fairly location independent for the most part. But there's others. So it's also quite elastic, and we're going to talk about that one for a little bit as well. But one of the features, again, of a cloud service is that it's all you can eat. So when you want more, there is more. When you don't need as much, you can scale back. Okay, so your use of the service can vary. So you're not fixed into these. You now buy 5 racks of servers, and now they all sit there chugging along, even though you don't have any work for them to do on the weekend. And then lastly, it's a measured service. So you pay as you use it. You pay per hour of CPU time, for example, or you may pay per gigabit transferred, either with or gigabit transferred or gigabit stored per month. But those are characteristics that we expect to see of a cloud service. But these are delivered in a number of ways. And there's basically the 3 major ones. So software as a service, platform as a service, and infrastructure as a service. And those are probably terms that you've heard, at least software as a service is quite a common term at this point. And I don't want to split hairs here, but to give you a broad idea of the difference between those three, you can consider three models. There's the Gmail model, the App Engine model, and Amazon's EC2 model. In Gmail, you don't get to choose which web application you run. You use Google's web application. All right? It's Google's webmail, and it's Gmail. All you can do is change configuration variables. That's it. That's the sum total of your administration of that service. And that's an example of software as a service. Someone else has got software, you're using their software. But they host it, they're responsible for upgrades, they're responsible for making sure that service stays available and all of that cool stuff, and you just make use of it as a service. Platform as a service is a little bit different. Within a platform as a service, what you find is that the provider gives you a runtime environment in which you can write your own applications. And Google App Engine is one example. There are others. But essentially, they give you a little sandbox, and within the sandbox, you can run your own Java, you can run your own Python, whatever you want. So you get to code your own web application. And in support of that, they'll provide you with databases, and network connectivity, and messaging services, and all of this stuff. But ultimately, you're responsible for the application. Everything below the application, though, Google still maintains responsibility for. So to make sure that the operating system's updated, to make sure that the runtime environment is kept up and so on is Google's job. And then the last service model that we have there is infrastructure as a service. And infrastructure as a service just goes one more level down. And it says that you get access to some kind of infrastructure, and everything on top of that is your responsibility. So Amazon EC2 does this, where they give you the ability to run a virtual machine. So they use a Zen-based platform. But everything from the operating system upwards is your responsibility. You get to put whatever you want inside of this virtual machine. So those are the three main services. Of course, platform as a service is not necessarily just about virtual machines. It could also be about storage on the network, or it could be about virtual private clouds, or there's many different ways in which you could hire infrastructure. But the common one is EC2. And then the deployment model is how these collection of services that you purchase are delivered to, or how they're presented to the client. So starting at the top, we've got a private cloud, and a private cloud is one in which there's only a single user or a single organization who makes use of it. So, one large company could virtualize most of their services, and they sort of collect this together in one of their data centers. And now everyone within the organization who wants to have computing resources uses their local private cloud. That doesn't necessarily have to be local. Amazon talks about virtual private clouds, where actually you've got a private cloud, it runs at Amazon, there's VPN links and so on. So it's a really, really fast-changing world. There's many options that are available. Community cloud is something you don't see as often. A community cloud supposedly refers to a cloud that's shared by like-minded and a closed group of organizations. But the more common one is the public cloud. So the public cloud is where we have services that are offered to members of the public. And all of the services that we'll look at today are in the public cloud. So we're not going to, are public clouds. So we're not going to be looking at any of the others. Christopher Hoff is a guy who's at Cisco, and he's sort of responsible for their virtualization strategy, and he's a really vocal, certainly, player in cloud and in virtualization. And he kind of put together this taxonomy and ontology showing sort of the different ways of, so those different service models and components within them. And here he's got the services that one would expect to find at each of these layers. And he's done a little bit of a mapping to commercial offerings for each of those. And it's starting to get, it's really starting to be fleshed out. OpenCrowd did this diagram in which they tried to put together a taxonomy of all of the companies who are responsible, or companies who are offering cloud services. And they use a very similar taxonomy. You'll notice they've also got infrastructure, platform, and software services, and within them all the corporate or the commercial offerings. But the one that they do add there is the makers of software that run in the cloud. So the makers of the software that support the cloud. And there you'll expect to see players like VMware and so on, and Zen. So what you can see is that there's many different definitions and many ways of looking at cloud. The one thing I should have mentioned on the NIST slide is that was version 15 of their definition of what cloud is. And it was updated December 2009, and I think they started early 2009 with that definition. So within a year, they've got 15 updates to a definition. So this is clearly something that's moving, and we're still trying to get a feel for what it all is. But we see this a little bit simpler, hence the really basic Venn diagram. And as security guys, we see it as, well, what is the stuff that's on offer, and how can we break it? So we get to break it down. And those taxologies and ontologies and so on are useful in trying to pick targets. But apart from that, we just want to look for issues. So why do we want to look for issues? Well, for one, it's going to be where the action is. So companies are moving many services into the cloud, and our customers are moving services into the cloud. They come to us, they ask us, is this secure? Should we be doing this? And so we need to go there. Inevitably, where your customers go, if you want to stay in business, if you want to help them, if you want to add value, you'll need to go where they go. And so this is where a lot of the action is going to be in the near future. It's interesting. We'll see a little bit later with Mobile.me that when it comes to cloud services, they slowly expand. And so they sort of slowly eat up the various services that one would normally expect to see either internally or new services that get added. And so from I'm not really a risk guy, but from a risk perspective, you've got a slowly changing risk over time. And it's hard to, you need to stop and measure every now and then to say, okay, well, what's changed between the last time we looked at this particular service? What have they added? What are the new features? Because it's rapidly changing. New features are coming out, as we'll see in Mobile.me. And one of the really interesting, one of the features of cloud is that mostly it's accessed through a web browser, and I'm going to talk about that quite extensively. But essentially, we haven't really got web applications right. Now we're putting all our trust in these cloud services that are accessed through these interfaces that we haven't yet perfected. There seems to be scope for things getting upscrewed. And we actually don't have to be making these mistakes if we're doing things properly. So, if we look at the things that drive cloud adoption, for the one you've got the so-called in-flight magazine effect. So your boss's boss goes flying somewhere, and he probably travels in business class or whatever, and while he's getting his massage, he opens up the magazine that's in front of him, and within the magazine there's a glossy one-page on how cloud computing saved some company 50% of their operational costs. And he comes out and he says, well, that's what we've got to do, because I hear this is the way to go, and it's great. And that's fine. We don't, a lot of decisions get made like that, but let's not fool ourselves. There's also the geek version of that. So geeks go, holy cow, I saw Amazon allow me to run any VM that I want through a web interface. That's pretty freaking cool. Let's play with the cloud there. So on both sides, you've got management saying, well, we hear there's a lot of buzz. Let's start to look and see if we can get cost savings. And on the geek side, we've also got the tech guys saying, well, this is actually just fun tech. It's awesome. And what we found through our playing with this is actually a lot of the services are very nicely thought out. There is some cool thinking in there. Not necessarily from a security point of view, but from a functionality and features point of view. There's another viewpoint that's also kind of growing in terms of why cloud is becoming adopted, and that's historically in organizations, people generally get poor service from the internal IT guys. So the mail server's down again, or the VPN's not working, and you have to hear a story about why this upgrade couldn't happen, or why you got taken out by this worm or or whatever. If you're a user of a service inside an organization, that can be quite a frustrating thing. And so when you hear the promise of cloud computing that's going to magically take away all of these things, then it makes sense that there's interest. Marcus Ranum, who some of you may be familiar with, who works at Tenable, who make Nessus, this is his comment on it. He said that cloud computing can be seen as the business unit's final revenge on IT and security for saying no one too many times, for taking too long, or for costing too much. So there's a driver for cloud computing that's not necessarily geek, and it's a push down decision. Of course, the economy is kind of picking up at this point. I guess really slowly, but the economy is down, which means people are looking to save costs, and so a pay-as-you-go model becomes quite attractive. You don't have to spend lots of money on big racks of services. Of service, you can just rent time as and when you need it. So your CapEx becomes OpEx. This is, of course, the CapEx OpEx thing. We leave private clouds out of that debate, so we're not talking private clouds today. And I mentioned that it's cool. It is really cool, bit like crack. Once you taste it, smoke it, whatever. You don't really. Everything else kind of pales into insignificance. But what we have found through when we were preparing this talk is that there are a number of problems that come out of testing in the cloud. So one of your customers goes out and gets they start with a cloud service, whatever that may be, and then they come to you and say, okay, we've now deployed this thing, our application's running there. We want you to test it. Or they say, we want you to evaluate this provider in preparation for us purchasing services from them. And what we came across was that actually this is still a very fuzzy area for testing things in the cloud. And there's big ones. So there's things like permission. If a company hosts their email with Google, so Google handles all their email, can you just start testing Gmail? Like, where is that line? There's a line, clearly. I mean, if you full on trying to hack Google, eventually someone's going to come at you. But there's a fuzzy line then. If you approach Google and say, we want to test your systems, they're going to turn you away. So there are many problems. For example, what happens if you do get permission and you're testing on a cloud service and you come across someone else's data? Now, depending on the country you're in, that may have privacy implications and so on. There's other issues that are not related to the legalities. So, for example, your customer says, test the service. You test the service. You get all the permission and so on. It's a cloud service, right? There's no version changes, or there's no version numbers that are exposed to us. What version is Gmail running at today? It's not beta. Like, that's about the most you can say. So let's assume that you managed to test Gmail today. What about tomorrow? What about the next day? It's hard for a company who are fixed on sort of change control processes and all of that when they don't know what is being changed at their provider. There are a couple of other issues, of course. Transparency is one. So you may remember last year, Amazon had an issue where they sold a copy of George Orwell's 1984. And it turned out on their Kindle device, the little reader device, and it turned out that actually they didn't have permission to sell that particular version. So they went, or remotely they wiped that device, or they wiped that book from people's Kindles. Okay. There's crazy transparency and privacy implications there. Of course, the fact that it was the book was 1984, the irony is just kind of piled on top of the sadness in that particular case. But Ed Felton, who is from Princeton, I believe, kind of commented on this, and one of the things that he pointed out was, he said, when someone else is responsible for your computing in a broad sense, so, cloud computing, transparency is key. You have to be able to know what it is that they're doing and what it is that they're doing to your data. I mean, when Amazon pull tricks like this, clearly they're not really being that transparent. So if we take that transparency is important, then it's kind of interesting, because Guido van Rossum is responsible for Google App Engine, and Python and lots of other stuff. And he did an interview with the cloud security guys, and I don't know if you can read this, but essentially what he says here, they ask him, what role do you think Google can play in building trust with its clients? And his response is quite a nice one. It says, our actions in terms of being open to our users will be the most important factor in establishing trust. Open to our users. Okay? So he recognizes transparency is important. Cloud security carryout. What security principles do you follow for App Engine? While I can't share any specifics on what we're doing to App Engine, okay, that's his response to that. Another question, please provide some examples of how those principles played out in terms of the current implementation. I'm sorry, we don't divulge that information. Next one. How do you contain an attacker that exploits bugs, blah, blah, blah? You are correct, is the answer, that strong measures are in place, but I am not at liberty to discuss the details. Okay. On the one hand, he's saying we need to be open with our users, but when he gets asked specific questions about, well, what are you doing? He's kind of coming up with a blank screen, a wall. And Pete Herzog, in his talk this morning, spoke to us about how you need to know exactly what is going on. You need to be able to look into the systems to see what they are doing. And when the response is, well, I'm sorry, we can't tell you or show you or let you look, then it's not something that engenders a lot of trust. So transparency is a hard, well, it's not necessarily a hard problem, but it's not a problem that many of the cloud providers have yet recognized. There's another big one, of course. The elephant in the room at this point is compliance. So compliance is kind of the dirty word that people hate, but it's now a necessity. And so one of the RSA security strategists is basically saying here that if you've got data that doesn't have any compliance regimes attached to it, then put it in the cloud if you want. But it's too early to say whether or not you can put data that needs compliance in terms of PCI or one of the other regimes. It's too early to say if that will go in the cloud. And part of that is because there's no direction from the compliance councils. So it is basically left up to your auditor to figure out whether or not your controls match, or whether your controls are sufficient. Now, PCI, for example, is they're trying to address this. Later this year, they've got version 1.3 of the DSS, and they're going to cover virtualization. They expect to cover virtualization in there. But we don't yet know what the final decision on that is going to be. So, bottom line is compliance in the cloud is really, really messy. Now, we can come across, or we can also talk the privacy and legal issues that one sees in the cloud. Mostly this applies, it was more applicable to the US, but essentially in the US, the Fourth Amendment to their Constitution provides protection against unreasonable search and seizure. In other words, you need a warrant, you need a judge to sign the warrant, blah, blah, blah. And I would naturally assume there's similar provisions in Europe. But in terms of cloud computing within cloud, because a lot of the stuff is remote, it doesn't sit on site. It sits in a provider's, the racks of servers. Your data is not, so your data can be seized without a warrant for that names you. An order for that particular data center is sufficient. And it means that your machines can be seized without a warrant, without you being notified. And this happened last year where a data center in the US was raided, and I think FBI confiscated everything. They literally took down a data center, gone, because there was an investigation that involved certain machines in the data center. But instead of figuring out which machines, they pulled plugs on everything, and all the equipment went out the door. So there's definite concerns there if you're a company who's relying on cloud services. Now, normally we get told, well, look, yeah, if you're worried about privacy or legal issues, the solution is crypto. Crypto is the magic pixie dust that when you sprinkle on things, suddenly it becomes secure. Let's appeal to authority again. But in this time, as opposed to the previous time, I think Schneier does have a point that's worth repeating. So he was the guy who said that if you think crypto will solve your problem, you don't understand your problem, you don't understand crypto. And part of that is because you can throw in all the crypto you want. If that crypto is running in the cloud, then actually you still don't have a trusted base from which you can rely on that crypto. So, I mean, crypto is normally hard. Well, it's almost always hard. And sort of magically throwing around AES 256 is not really something that engenders a lot of trust without a lot of deep thought. Vendor lock-in is a big one when it comes to the cloud. So, you know, it is relatively self-explanatory. But if you are developing, this is quite an important one specifically for platform as a service models. So where you are writing applications that run on someone's, or run inside of someone else's runtime environment, that runtime environment often has quirks. It'll have specific APIs. It'll have things that are, you know, custom for that API, or for that environment. And it makes it quite hard to just port that. Not to port it. It makes it quite hard to just shift that application if you're unhappy with that particular provider. And for example, with an app engine that is less so, you're still writing in Python, but you're going to use Google's libraries. And they've made some effort to allow you to write it in one of the common web application frameworks, your application, and then it'll run cleanly on App Engine. But if you look at a company like Salesforce.com, which we'll look at a little bit later, Salesforce.com has got a completely custom language that you write your applications in. So once you've written your application in Apex, which is their language, you're not shifting that thing off Salesforce.com. So lock-in is an issue that definitely needs to be considered. There's also questions of data and who owns the data and so on. And so when it comes, again, to running things in the cloud, one of the promises that we're told with cloud computing is the guys who run, or one of the big benefits is that these guys do this job and they do it really well. So they manage, you know, servers that are supposed to stay up. That's their job. That's what they can do. And so the premise is that you've got 2 IT admins in your company. Yeah, they kind of know their job. We've got a team of 50 guys who monitor all our servers, and so we'll do this much better than you. And of course, chances are that they are quite good at what they do. But this doesn't mean that they're fallible, or infallible, sorry. So these are just a bunch of screenshots that we came across while we were testing. But Cloud Files is a storage provider, and so at a point, you know, they go down. Pretty much all your data is still there. It's in read-only mode, though. But if you're relying on this thing to do business, well, you know, the system is offline. Which is, if you come to South Africa in 3 months, probably something you'll hear quite often. That's we get the system is offline in many different places, post offices, shops. It's a common thing. Hopefully not the soccer tournament. Like, hopefully we've got generators, so the power should be okay. There should be lights. But, yeah, no, hopefully for the soccer, we'll be all right. Sugarsync is another storage provider, and they're quite a large storage provider. And this is another example of them being off. So basically here they're going through routine maintenance and updating their site, and they'll be back online. It's a 3-hour window of downtime. One of the interesting things is you don't get to control that. So if that happens to fall at wherever you are in the world, midday to 3 p.m., tough. That's not really something that you can control. So this is another one of the concerns that you need to be aware of. And then last year in July, Google App Engine, some of you may recall, was out also for 6 hours. So they had a kind of an underlying issue in the Google file system. And this thing cascaded through to the data center in which App Engine apps ran. What was interesting was that App Engine at that point ran solely in a single data center at Google. And pretty much this is a series of mails talking about, sort of giving you updates as this thing went on. But basically for 6 hours, App Engine was shaky and eventually was completely offline. And that's Google. So their response is outstanding. I mean, they've got, within sort of an hour and a half of the fault, they've got the Google file system engineering team debugging this thing rapidly. So clearly, they recognize the urgency in getting this sorted. But there are, the scope or the possibility for downtime doesn't disappear with cloud. Not at all. This is another example of availability, but not in terms of systems going down. What happens if your provider gets sold? It's still early days for cloud. There's still lots of small companies who are playing in this space. And so here's an example of USA, who they've been acquired, the message says, and then pretty much what's interesting is they say, well, once the transition is complete, you'll get your data back. Like, who's getting my data should be a big question. Like, who's bought you? Do the contracts that I signed or the terms and conditions that I signed with you carry over to the new company? All of these things are questions that need to be asked. Here's another example. So TechCrunch did an article last year. They talk about a company called OmniDrive, and they give OmniDrive a bit of space. But if you go to the OmniDrive site, what you'll see is that OmniDrive no longer exists, and now they're recommending to you another place called Nomadesk. So it's a rapidly changing field. Of course, carrying this even further, because availability is one of the strong selling points in terms of cloud. So if you put aside the systems going down, if you put aside the systems getting sold, if you look at malicious activity, what does this mean for things like account lockout? If you're reliant on that service to do business, and there's some kind of authentication that you need to do, and someone else is able to lock you out, well, what happens now to your ability to do business? So account lockout, we still, and this is this is a point that we'll raise with the web application side of things. But when your management interface, or if the access to the system is through a web application, that historically we're kind of only wrapping our brains around sort of what it means to have a secure web application at this point. And now you're chaining behind a web application all your infrastructure. Are all of the controls that we're used to in a web application, a username and a password and maybe a captcha, are they suitable to protect all of your infrastructure? So, to keep going, a company called MediaMax, they ran a script. Shame. You got to feel sorry for the guy who ran the script. Basically, they were trying to purge inactive accounts. There was a mistake in the script, and it purged active accounts and their data, and it took them out. They never recovered from that, so their customers all left them, and the company closed down. So kind of a fat finger in a script was responsible for the company going out of business. Nokia's Ovi store lost 3 weeks' worth of data. Salesforce.com, January last year, was having issues with core network equipment and so on. You may remember recently, now October 2009, so 5 months ago, sorry. Microsoft runs the Sidekick, or has the Sidekick product, which is a little mobile phone type device with cloud backing and contacts and pictures and all of that stuff. And there was an issue with the storage for Sidekick to the point that they lost all the customers' data. Gone. And at the time, they were talking that the data was irretrievably lost. It took them a month and a half to recover the data, so they got the data back. But in that time, they were no longer or they suspended sales of the device, and clearly you've got a lot of upset users. So when you put all of your eggs in one basket, the basket drops, all your eggs are broken. You may recognize this guy. We'll appeal to him again. So that's Dan Geer. And he had a thesis or more than a decade ago about monocultures in computing, to say that when you have many systems that are identical, and in his case he was talking about Windows, as soon as a vulnerability appears in one of those systems, they're all vulnerable. And so it makes it, the weakness is shared. So the whole system is quite weak, as opposed, and so he comes from a biological sciences background, and I think his thinking is strongly based on that. But you don't have a heterogeneous system which is able to resist multiple attacks. As soon as one system is vulnerable in a homogeneous system, then everything is vulnerable. And it's a it's a principle that many people do accept. His was for Windows, though, but actually does this carry over into cloud? Well, let's look at a company called SmugMug, and SmugMug does file and video sharing. Some stats they released last year said they were processing more than 50 terapixels a day, which is a lot of pixels. And they were definitely a poster child for EC2, which is Amazon's, or one of Amazon's services. Excuse me. And so they made use of both EC2 and S3, which is the storage service. And they did cool things, like on one click of a button, they launch almost 2,000 instances of their sort of virtual machine that they parallelize tasks over. But it doesn't get more homogeneous than 2,000 instances of the exact same machine. Like, we're not even talking about minor differences. It's the exact same machine. So that monoculture argument starts to move into the cloud, which is just an interesting observation for the most part. When it comes to the cloud, we're also extending the attack surface. So where normally, if we agree the perimeter is dead, but there are points that we try to protect. And when it comes to the cloud, well, now you've got more points. You're extending the attack surface. And it becomes interesting because something like your cloud provider getting phished means that you would have an issue. So you've seen, or you probably recall to a large degree, the Twitter attacks of the past year and a half or so. How Twitter can't seem to get security right, and every time that someone manages to guess an admin password, or someone manages to take over an admin's old email account at Hotmail, and then can log into Twitter on the admin panel, then, all these celebrities and other well-known people get their data broadcast or their accounts hijacked or whatever. And you also saw this with Salesforce, again, incidentally. November 2007, Salesforce had one of their employees was spearphished. So one of their employees was sent a specific email, blah, blah, blah. His credentials were stolen. And so attackers were able to log into Salesforce.com, get a list of customers and start. In fact, in effect, the attack was lame. They were trying to spam the customers and so on. But if your data is sitting in the cloud and the cloud provider is not taking adequate precautions on security of your data through basic things like phishing, so it works against home users for their bank accounts, you don't really expect it to work against employees of a large cloud provider. But experience shows that it has. It goes a little bit further, though, than just even your data in the cloud. So it used to be that phishing was maybe a lost individual account, but now it means that if someone is phished, it could be your infrastructure that's gone. So here's something to consider. When you sign up for Amazon EC2, if you already have an Amazon account, i.e. to buy books, then you can use the same account. So one option, and I guess we can talk scenarios, but one scenario that is possible is the CFO or whoever who signs up for the service uses his own personal account to do this, because He's sick and tired of IT saying no, and he wants this project to get off the ground. And so he just uses the same account that he uses to buy books, to buy his company's resources, computing resources. And so in his head, he's still thinking of this account as, this is the account that I use to buy books. Meanwhile, actually, this is also the account that he can use to manage all his infrastructure. So Amazon provides you with a single entry point where you can either buy books or you can buy hundreds of computing hours. It's a great store, so the feature is awesome. But from a security perspective, there's questions. This is a conversation that Harun had with a guy online. And so pretty much what is one of his friends online, and pretty much the guy was talking about Kostya's cloudburst attack, which was a guest to host escape. So in VMware, if one was within a virtual machine, one could break out into the host, which is an extraordinarily scary attack. And so he expresses this horror, saying, look, this is scary stuff. But Harun's point here is that it's a right to be concerned about such attacks, but there's no indication that Amazon isn't owned either. So why would you be more concerned about Kostya's attack than Amazon doing bad things? And well, the one argument says that, look, you trust Microsoft with your operating system. Why don't you trust Amazon with their platform? But it's a little bit of a red herring. There are differences, and it's important to look into what those differences are. And so you can complete that phrase, trust, but anyone? Verify. Thank you. Trust but verify. And so we've got the trust part down because we're running their service. But the verification thing starts to become shifty. So verification under Microsoft, so with Windows, when you run it on your own machine, to a degree is always possible. So you're reverse engineering whatever components they have. You can look into it and see exactly what's going on. It's now a good number of years ago, someone found strings in Windows DLLs with NSA at the start of the strings, and they were related to crypto. And a number of people threw quite a fit about it. And it's an indication of the verification that can happen. So people look at what is on their system. They can monitor the outgoing network traffic. They can see, exactly what's happening. But when it comes to what Amazon's doing, that's not so clear. So the verification with Amazon is absent. You can't go to Amazon and say, okay, I'd like to plug into the server on which my AMI is running, and now I want to do some tests. You'll get laughed out of there. This relates a little bit back to what we were talking about earlier in terms of the versioning of systems. So if you manage, for some degree, let's assume you purchase Windows, you go through your whole verification step, whatever that means. But you get to a point where you say, okay, now I trust the system. That's cool. At that point, you've got that software, you can use it in your organization. When it comes to Amazon, even if you go through that whole verification step, however that may or may not happen, there's no guarantee that the next day that system remains constant. Okay. So the verification within cloud is what is lacking, and why I think many of us have these trust issues. So sort of a sidebar, I guess, it may actually be more of a common story here. Crypto AG, anyone familiar with them? Basically a company who for 50 years was supplying crypto to companies and governments around the world with a really good reputation. But it turned out that actually they were kind of a front for NSA in the US. It's an interesting article. You should read it up. And so this company that had been trusted but hadn't permitted verification was doing bad stuff. So it's not a huge leap to say, look, Amazon, you're nice guys and you've got cool services and we'd like to trust you. But we need to be able to verify. If we want to trust you fully, we need to be able to verify your services. We'll take another small little diversion and we'll check out some of the uses for cloud. Actually, I'll go through these really quickly. So there's basically 3 uses here. We've got Dino Daizovi, Ben Nagy, the Dynamics guys, and David Molnar. And pretty much this is how guys are using it. So with Dino Daizovi, you'll remember the Debian OpenSSL fiasco. Pretty much there were a fixed number of keys that could be easily generated that would be produced when one was trying to create sort of a whole bunch of crypto, actually. But he tied this to SSH specifically. And so pretty much he generated a whole bunch of, well, all the possible RSA keys in this case. And it took him 6 hours at a cost of $16 for about 500,000 keys, which is quite a cool little use of EC2. Okay, so he had that computing on tap. He turned on the tap, ran all his computations, and had his answer. And then didn't need to hold on to racks of servers. It's quite interesting. Ben Nagy spoke at SciScan about a fuzzing harness that he's developed, a fuzzing platform, where pretty much he brings up virtual machines, he fuzzes stuff inside them, monitors them for crashes, pulls out the results, dumps into databases, and so on. But it's happening in parallel, and it's also quite a nice example of how to use the cloud. And then the guys from Dynamics, who I suspect would be well known to you, also have made use of EC2 to classify malware. There's also a project in which open source software was fuzzed on EC2. So this gives you an indication now of some of the players in the cloud, but actually we're really interested in 3 of them for this talk. So MobileMe is Apple's sort of cloud service. Salesforce.com is a commercial service that deals mostly with CRM softwares, but it also has a platform as a service component. And then Amazon, which is the well-known one. So just to give you a taste, I spoke earlier that Amazon allows, or elasticity is a big component of cloud computing. So this is an example of a customer's usage of CPUs over time. And what you'll see is that it spikes when they actually need the computing power. So during the day, when they're actually doing processing, they need the CPUs. On the weekend, it can drop off. And you pay based on how much you use. So it's quite a nice feature. But there's got to be a little bit of a concern here. It means that if someone else can drive your usage up, and depending on how your elasticity is configured, it could cost you more directly. So a competitor could quite easily, it used to be tough to cost people money. Well, not necessarily tough, but now it's really easy to cost someone money. You can just wget in a loop a really expensive or a really process-intensive page on his site. Storage as a service is one of the other key components that one sees in cloud computing, and it's also quite a common service that you'll see. So there are many providers. It's probably the most common service that you'll see when it comes to the cloud space, and it's quite a simple thing. There's a whole bunch of reasons why it becomes useful. So for one, it's available from wherever you are. You just need an internet connection. You're not limited by your own storage locally, so you don't need to buy new drives. You just pay as and when you need more and more data, and you're paying per gigabyte. So it's quite useful. But often we get that web application interface that's thrown on top of this thing, and if there's one thing we know about applications is that mostly we're doing it wrong. And so now we've got applications that we generally don't know how to build, and we sort of stick in file systems behind them, and it seems to be a recipe for some disaster. So for example, Amazon, with EC2 in the early days, so 2006, when they would re-provision a machine, in other words, the machine had been, they were installing or they were putting in a new virtual machine or whatever, the previous disk usage for that machine wasn't wiped or cleared. So it meant that you could just boot up you could boot up an image and start going through the disk sector by sector. Even though you're looking at it from inside a virtual machine, you're still just reading sectors of the disk. And you can pull out information from the people who were using that machine previously. So you get documents, you get photos, and so on. And that was demonstrated. But these days we've got, there's a service called Steeker, and they were purchased by F-Secure, so the security company, with the goal being to do secure storage in the cloud. And so they've got sort of the little marketing spiel there. But a guy called Russ McCree found actually a relatively stupid cross-site scripting vulnerability in their service. So you are relying on the service to provide you with access to your data. So they're a disk, they're a storage service. But actually, their web application has got cross-site scripting in it. And in this case, it was persistent cross-site scripting, which is a little bit worse. Well, it's worse than reflected. And so, these guys, who are supposed to be a secure storage provider, that's their stated aim, are not really getting it right either. Apple have their iDisk service. So this is, again, another example of a storage service. And it lets you store whatever you want on their or in their cloud. And so you can upload from either your iPhone or from within iTunes or whatever, or even from the Finder. And so Jeremy Richards, in this case, showed us this example. So here he's got his iDisk, which is, as you can see on the left, just accessible as another volume. And this is the contents of his iDisk. But one of the features of iDisk is that you've got a public folder. And so it means that anyone can access your public folder on the net. And we'll show you an example of why that's bad later. But what he puts here is he puts a private.txt outside of the public folder. So it should not be accessible to the public. And there's the contents. But what you find is that you'll see there, jeremy.richards-public / and if you're familiar with %2e, you'll know that translates to a dot, a period, a full stop. In other words, we're talking directory traversal. Really? Directory traversal in this day and age? Unfortunately, yes. Directory traversal on Apple iDisk, which is incredibly lame, but it's there. And so one of the big guys within the storage service is Sugarsync. But before we actually talk Sugarsync, I want to quickly talk a little bit of a diversion. You're probably all used to brute forcing logins to pages. So typically you try to log in to a page, you get back, sorry, your password's not valid, or your password's invalid. You do this a couple of times, you get your password is invalid. Maybe finally you get the correct password, you get a message that says, welcome, Bob. But what happens if you don't know about the welcome Bob message? Then it becomes a little tricksy. So one way to do this is to kind of get a signature for what an invalid login attempt looks like. So you do some string calculation on the page. And then you always check against that string calculation to see if it matches. And where it doesn't match, then where it matches, it's a failed login. Where it doesn't match, you don't know what that is, but you know it's not a failed login. Maybe it's another, it might be in this case another error message, or in this case it's the welcome message. Okay. Problem is, sometimes you get kicked out of, or you get locked out of an account. In this case, you can just try and brute force usernames with a constant password, and you may get some luck. But actually, all of that is a lead up to getting a session ID in most applications. So a cookie is, in common applications, it's the most popular way of handling authentication. It's an authentication cookie. And so actually you're only ever trying to get back a valid cookie that's tied to someone's session. So the question becomes, well, can we brute force cookies? And generally the answer to that is no. I mean, it's at least 128-bit number that you're trying to brute force. And so the chances of you getting through that space are quite small. The idea is nice, though. So if you could brute force every cookie on a site, then eventually you'd find one that that matches. Of course, there's statistics are fun in this case, and so you can improve your chances with some random selection. But we did look at this company called Sugarsync, and what was interesting and why it ties back to the brute forcing is exactly this. So I'm going to show you a few videos, and then we'll go, I think, to the first break. Okay, so, this is just, the login kind of takes you through a bit of a flash thing. Okay, so we want to log into Sugarsync, but we don't know we forget our password. So we follow the forgot password process here. So we enter in our email address, and what happens is you'll see down there, up will pop a little notification to say that the email has been received. Okay, so the email, they send you an email, and inside the email is a link. And the email has that link that you see in the middle, and pretty much it's a reset link with a token. Okay, so you need to present the token in order to reset that password. And of course, once you enter in the token, then you get to reset your password. Okay, but that's pretty much what a link looks like. And you'll see there that link is, it's not as big as, just looking at it visually, it's not as big as one might expect a cookie to be. And so, where does this leave us? So we do some silly maths, and we'll, like back of the envelope stuff, and you'll find that that's actually still a really big number. It's sort of 2.2 billion possibilities. That number is 2.2 billion. All right. If we're trying to guess things, birthday attack becomes quite interesting. But it's still a really big number. We need to guess 2 billion. But they've got an interesting approach to their account or their password reset, and that is that you can submit as many resets as you want, and that token, all of these tokens are valid. So they don't overwrite tokens, they just add tokens to the allowed reset token list. So we try to script this, and we try to brute force this. Just over 2 days though, and in 2 days, essentially we tried 2.2 million tokens, which is a small subset of 2.2 billion. So it's not that much. But the question, the more interesting thing for us is, well, won't they notice? They're getting loads of reset requests. They're also getting loads of attempts to guess other reset links. Surely they'll notice. But actually, they didn't. So we put in a bunch of work doing things like, the obvious stuff, actually. So we multi-threaded it, so I'm not going to go through that video. But the more interesting, I think, the more interesting aspect of this was the fact that 2 weeks later, so after we went through this attack, 2 weeks later, these reset links were still valid. So you can attack this problem on two sides. On the one side, you can try to guess random links, to guess anyone's link out there. But on the other side, you can also generate as many reset links as you want for a given account. So if you know the address of someone whom you are trying to attack, you can submit 5 million reset links on their behalf. And on the other side, you can try guess one of those. And so your probabilities start to increase. For us, what we found, though, was that time is still an issue. And so in this case, we didn't have permission from these guys to test their system. And so this is one of those murky areas. So we didn't go further than this. We wanted to demonstrate the potential. But, generating 500,000 reset links is probably borderline, at least. Okay, I think we'll stop there for 5 minutes. So remember, this is a 2-hour presentation, and we started at about 22. So it's now 22:12. So we'll take 5 minutes break, and we'll carry on afterwards.